Well, thank you, everybody here. It's a wonderful conference to be to. This is my first time coming to the CADFEM Conference. Let's give a big round of applause to our friends at CADFEM for such a wonderful conference. Thank you. Thank you, CADFEM. So, do you sometimes find yourself wondering, what is this cloud thing? Does it help with my simulations in any way? Can I use the cloud in any way? How do I use the cloud? If you have questions like that, then that's what we'll talk about today. So my name is Sandeep Sovani. I am with Amazon Web Services. Amazon Web Services is the world's leading cloud provider. I have the responsibility for heading the go-to-market for Amazon for the engineering simulation segment. And through this role, I get to work with dozens and dozens of customers and dozens of partners. And I see how the customers are benefiting from running their engineering simulations on the cloud. And I want to show you a glimpse of that today. So first of all, what is the cloud? We have different notions of what the cloud is. You might think of the cloud as something like this. Big set of servers and computers put together by a cloud provider, Amazon Web Services, that is made available to you to use on demand. You might think of it like that. Well, that's true to only half an extent. So this massive infrastructure of servers, storage, networking, all of that put together for you, and I'll talk about how big it is in just a little bit, is only half of the cloud. The other half of the cloud, you can think of it as the operating system of the cloud. It's software that sits on top of this infrastructure, and that makes this infrastructure available to you very easily. So think of it like the operating system of a computer that makes the hard disk and the processor and all of that available to you very easily. So that's the hidden part of the cloud that we often don't think of when we think of the cloud. And that enables you to, instead of doing this work of building clusters on your own, it allows you to build clusters like this for your high-performance computing, where you can simply write a code, and that code talks with the operating system of the cloud, and it will stand up a HPC cluster for you. Again, this is a code. You can do this with a graphical user interface and all of that. And this is a service. That's why Amazon Web Services is called as Web Services. Everything is available as a service through a graphical user interface or through APIs like this. If you can read the second last line over there, it is PC create cluster. When that command is executed, a cluster is stood up for you. You don't have to lift a single screwdriver in your hands. So this is an example of a data center that we have in Northern Virginia, one of our regions in North America. And to give you an idea of the scale of AWS, so you can imagine, there are thousands and thousands of computers and petabytes of storage in a data center like this. We operate out of 33 regions in the world today, and they keep on changing. There are 6 more coming soon, including one here in Germany. We already have one in Frankfurt, close by here. There's a second one coming here, as you can see from the red dots. Each region is made up of multiple what are called as availability zones, and each availability zone is made up of possibly multiple data centers, like the one you saw in the previous picture. So it can give you an idea of the enormous scale of the cloud. It's thousands and thousands of times bigger than the simulation infrastructure that even the largest company has today. Now, a quick fun fact about AWS. AWS started about 18 years ago, roughly in the mid-2000s. And it came off from an idea. At that time, Amazon.com was having a lot of their own infrastructure for running the .com business. It came from an idea of why don't we make this infrastructure available to other people to build their businesses on. And it was a very risky bet. You see that article there from Business Week back then, which writes about Wall Street thinking that Jeff Bezos should just mind the store and not do a risky business like this. But that risky step is very classic Amazon, disruptive innovation at every step. And that risky bet has grown into the world's leading cloud, very quickly grew into the world's leading cloud. And still today, in 12 consecutive years when this has been measured, AWS remains the leading cloud provider in the world. So coming to engineering simulation, as you see, cloud has been around for a decade and a half now. And what I'm seeing right now is there is a mass migration of customers wanting to utilize the cloud for running their engineering simulations. Engineering simulations have been run on premises for the last 20, 25 years, right? You might have a desktop on the user's desk, or there might be a cluster in your cluster room, or you might even have a bigger data center somewhere on your premises. So everything has been run on premises. Today, still about 95% of simulation is still done on premises, but we are seeing that customers are rapidly looking at the cloud, and the rest of the talk will talk about why customers are doing that. Here you see the statistics that the on-premises HPC growth is around 7%, and the cloud HPC CAE growth is about 18.5%, and just 3 years from now, the simulation on the cloud market for the infrastructure is expected to be $3 billion. So here are examples of some customers, AWS customers, who have chosen to give us public references for how they're using AWS technology for their simulation and related work. And you can see there are customers here from startups to large enterprises that have been around for nearly 100 years. They're across different industries, manufacturing, aerospace, automotive. These are all public case studies. You'll find them. I'll reference these in my talk, and there are references that you can go to read more information about these case studies. So, and as you know, the number of customers who give public references tends to be small compared to the actual number of customers, right? So you can imagine how much simulation is already being done on AWS, but that is still less than 5%. And most of it is still done on premises today. But there is a big movement happening of customers moving over to the cloud. So why? Why are customers doing this? And what are the benefits that are driving them to do this? So we can think of this as 8 different benefits that the customers are getting by running engineering simulation on the cloud. And we'll look at each of them one by one, and we'll look at some of those customer examples for these. So let's look at the first 3 together, because they go hand in hand. The first one is the massive capacity of the cloud. I just told you, I showed you the regions that we operate through and the data centers that there are. The capacity of the cloud is truly massive. If that capacity is harnessed for your simulations, it means no waiting in queue, which means higher productivity for you and your engineers. The second thing is that you can utilize that capacity in a pay-per-use sense, which gives tremendous business flexibility. You can spin up a large number of resources when you have big simulations to do, and then you can shut them down after they are used, and you only pay for what you have used. And all of this gives tremendous elasticity, including the fact that you can build up and tear down HPC clusters just as code. That's enormous elasticity that you can get. So let's look at the chart on the right-hand side. This is how the utilization changes. This is an automotive company running everything, all their simulation on the cloud. Their utilization changes like this throughout the year. You can see, for example, during the weekends, there is a drop, and in December, during the holidays, there is a drop. If you look at the average, the peaks are about 2 times the average. So now, typically on-premises, you buy a cluster for 3 years, and then you have a constant capacity for that cluster. So you size the cluster for the average, maybe a little bit over the average. But then the peaks, when you hit the peaks, you have to wait in the queue. Engineers have to wait in the queue. And that waiting in the queue can have 10 to 20% loss in productivity if the jobs are not turned around then and there. This example that I showed earlier, for this company, the queue time is 0. There is no waiting in the queue. Whenever a job comes in, new resources are spun up automatically on the cloud, the job runs, and then the resources are shut down when the peak goes off. So here's a customer example, one of those customers, Baker Hughes. I have a reference link to that. You can read the case study in more detail over there. But what Baker Hughes was able to accomplish is 98% less wait time. So as I mentioned, you can virtually eliminate wait time. And this is what Baker Hughes was able to do, virtually eliminate the wait time, as well as run their simulations faster with the latest technology that's available on AWS. Another example is from Wabtec. So Wabtec also set out for exploring the cloud for the purpose of reducing their solve times as well as wait times for their engineers in the simulation queues. They were able to achieve a 70% reduction with what they had before for fluent runs. And they were also able to get a better ROI with the cloud. So those are just 2 of those many examples that I showed to you. The 4th reason why customers like the cloud is, on the cloud, you always have access to the latest technology. Here's an example of a latest processor technology, but this applies to same things, storage technology, network technologies, etc. So look at the chart on the top. So if you have an on-premises cluster that you buy for 5 years, year 1, year 2, year 3, you still have the same processor, generation 1, all the way. But on the cloud, whenever the chip manufacturers release a new processor, we install those new processors on the cloud. And you can get a performance increase for every generation of the cloud. And as you know, as per the Moore's law, performance keeps on increasing, and you get benefit of that. And that's illustrated by this benchmark. You're familiar with the standard Ansys mechanical axle stress benchmark. Here you see the performance. So the vertical axis is solves per day. The higher, the better. Solves me per day, meaning how many times this problem can be solved in a 24-hour period if you keep on solving it one after the other. And on the horizontal axis are the number of cores that are used for running the job. So obviously, as the number of cores increase, the solves per day increase because of the scale-up of Ansys Mechanical. But the point I want to illustrate over here is if you look at those 2 orange lines, the lower orange line is for the 5th generation processor, and the upper orange line by the circles is the 6th generation processor. And the difference, depending on how many cores you're using, the difference in performance is 19 to 30%. You can get 19 to 30% faster turnaround time by going from one generation of processor to the next generation of processor. So if you look at 5 years, and you assume, let's say, 20% performance increase, which is sort of the lower end of the bound that I just showed you, that means almost 50% more throughput over the 5 years lifetime of the cluster. So with everything else remaining the same, your license pool remaining the same, everything else remaining the same, you're getting 50% more by having access to newer processors. So that was an example of Intel processors. Here's an example of AMD processors. Our partner Ferrari has been using AMD processors, and they have been testing different AMD processors. So they say that the latest generation AMD processor for high-performance computing, they saw a 30% improvement for their CFD jobs, and 25% improvement for their finite element jobs. And Ansys. So Ansys also does these sorts of benchmarks for various AWS processors. Here's a quote from Siddharth. Many of you might know Siddharth, that there was a 30% improvement from one generation of the Graviton processor to the next generation of the Graviton processor. The Graviton is an ARM-based processor. It's a chip that is developed by Amazon. So you might not know this. We typically think that Intel and AMD make chips, but Amazon also makes chips, and Graviton is the name of our chip. So that's the performance increase from one generation to the next. So this is all real, big performance gains from one year to the next, and you can get advantage of that on the cloud. The fifth reason why customers come to the cloud is the global presence of the cloud. I showed this slide to you earlier, 33 regions serving over 245 countries around the world. With this infrastructure, customers often have engineers sitting in different parts of the world these days. We are very international organizations these days. You can implement the same code that I showed you earlier. You can implement it in the Mumbai region, in the Frankfurt region, in the Ohio region, and have clusters stood up in a systematic, standard way for your users anywhere they are around the world. So this is an example of that from Vitesco, close by over here. So their global teams needed speed for their simulations and their development, and they got that by being on AWS. So simulations that used to take a week before are delivered now in one day, and this can be done across the globe for their engineers that are across different sites. The sixth reason is disaster resilience. And this is something that is oftentimes overlooked until disaster really strikes one day and there is a problem. So here you see a picture of the CTO of Amazon. His name is Dr. Werner Vogels. He has very nice and entertaining videos if you want to watch them. He's a really, really good person to watch. So look at some of his videos. He has said once that everything fails, and we have to embrace this failure as a natural occurrence. And we have done that in architecting Amazon Web Services, the cloud. For example, this Amazon S3, which is our simple storage service, S3, that has a durability of 99.9999, 11 nines after the decimal, which means if you put your data on Amazon S3, it is virtually indestructible. And that level of redundancy is built in the cloud, and you can build that redundancy. And it comes in handy when disaster really strikes. So look at this example. Rivian, a car company that is coming up very rapidly. They started off with an on-premises cluster for their engineering simulations. And one day in 2020, half of their compute capacity was gone because of a disaster, because of a failure. So imagine a car company that has pressures to bring a revolutionary new product to market, and half of their compute capacity is gone one day. How much pressure that would put on that company? So they turned over to AWS, and they were expecting it would take 6 months to put together a new cluster, a new environment. They were able to have a proof of concept running in 3 weeks. So that's the sort of business flexibility you get, but also disaster resilience. Because of all of those extra regions and data centers, and your clusters being created by a code, you can have other infrastructure waiting for you if your infrastructure ever fails. So that's one hidden reason why customers prefer the cloud. You get excellent disaster resilience on the cloud compared to on-premises. And finally, it all comes down to cost. And our customers see that if they do a true true apples-to-apples comparison, then the cloud costs less than doing HPC on-premises. And that's one of the biggest drivers for customers to come over to the cloud, because ultimately it costs less. Now, to do a true apples-to-apples comparison, you have to consider not just the compute core hour cost, but a lot more. You have to look at the cost of the storage, the data center operations, the licenses for all the services that you're using, networks, data, administrative services, billable services, all of that. If you look at all of this holistically and do apples-to-apples comparison, you will find that the cloud is less expensive than doing HPC on-premises. And I help our customers do this sort of calculation every day. And then customers realize the benefit of the cloud. The last reason why customers choose the cloud is sustainability. So there have been studies that show that the AWS infrastructure is up to 5 times more energy efficient than a typical European data center. That's because of the commitment that Amazon has to powering all of our operations by renewable energy by 2025, which is just next year. We started this several years ago, and we are well on track to meet that target. So out of those 33 regions that I showed you earlier, by the end of 2022, 19 were working on electricity that is attributable fully to renewable energy. So what this means is that by moving from on-premises to the cloud, you can immediately gain sustainability advantage that you can utilize. So if you think about it, then those are the reasons for which customers, 8 reasons for which customers are moving to the cloud. So how do we move to the cloud? How do we use the cloud? If there are all these benefits, how do we do it? So first of all, the cloud works, the way we work is in this way, where you bring your own Ansys licenses, and the infrastructure is provided by AWS. The infrastructure comprises of AWS products and services that is provided by AWS. You get your licenses from Ansys, and you bring them over. You get your licenses from CADFEM, you bring them over. The AWS simulation environment, I won't go into details of it, but it's made up of all the essential elements: compute and storage and orchestration mechanisms and visualization mechanisms, portals for your users to log in, et cetera. All of that technology stack is what is provided by AWS. You see names of different services over there for file systems or for compute instances, et cetera. So how do you access all of that infrastructure that AWS provides? There are 2 ways to do this. One way is by using Ansys Gateway, powered by AWS. This helps you to create and customize your applications and run them on the cloud with minimal technical skills related to the cloud. And then the other way to do it is through AWS native services. These are used for creating high-end custom HPC systems by large customers. They use native AWS services to do that. So just as a quick recap, Ansys Gateway, powered by AWS, works in a way where you have your own subscription for the cloud, and then you use Ansys Gateway to run your Ansys simulations on the cloud with the licenses that you bring on your own. And then you get the interfaces, the ease of spinning up and spinning down your clusters. So that's the easy way to do this with Ansys Gateway. If you have to do it with AWS native services, this is a complicated architecture diagram, but I want to show this to you, is you get all the bells and whistles to tweak and do the adjustments on your own, but it means that you have to build a system like this. We provide reference architectures like that, but you have to build a system on your own. And it's doable. Many customers do that. And this is where our partnership with CADFEM and Ansys comes together. So we are working closely with both Ansys and CADFEM. CADFEM can help you on both of those paths, Ansys Gateway, or if you want to do a implementation with AWS native services, CADFEM can help you with that. So that's all I have. Thank you very much. And we'll talk later if you have any questions. So thank you.